Hopefully you figured out that in question letter B, an equation could have a minus sign if the adder was a negative number. If I was subtracting something, then the adder could very well be negative, and that makes perfect sense. In fact, if you go back to the Desmos and just kind of think about it, there were a couple of equations, blue cards, where there was a minus sign instead of a plus. So it actually stands to reason that a minus sign or a plus sign can be used interchangeably, depending on whether your adder is positive, if you're truly adding something, or if your adder is negative and you'd be subtracting a pattern. Now, in letter C, let's see if we can practice building our own equation. In letter C, it says we have an arithmetic sequence that has an initial value of 15, and each subsequent term is 3 bigger than the term before it. Let's do a little translating. First of all, it's telling us very clearly that we have an initial value of 15. So I'm going to think about that for a moment. Initial value is familiar. I've seen that phrase before, and I'm going to kind of color code it so you can see where I've seen it. Initial is that first number in the equation. Initial is something I need in the equation. It says afterwards each subsequent term is 3 bigger. I'm thinking of 3 bigger. Bigger makes me think of adding, because you're making something bigger when you add. So I'm immediately thinking that this 3 bigger must be referring to the adder part of the equation. So let's think about this for a moment. If I had an initial value of 15, and I'm just going to make a little table to organize my thoughts, but you don't have to do this. You might just want to kind of follow my logic, but not necessarily do a lot of work here. If I had an initial value of 15, so that's where the 0 term is 15, then I would think, okay, well, what would come after that? The next term, because subsequent just means next, that's a fancy word there, but the word subsequent just means next in this context. The next term is 3 bigger. So if I'm at 15 and the next one after that is 3 bigger, that means the next term is going to be 18. And if the next term after that is going to be 3 bigger, then I'm at 21. And if the next term after that is going to be 3 bigger, then I'd be at 24. So if you think logically, we actually have the information that we need. The initial value is 15, I know that, and the adder is 3. So if I translate this information into this structure, then I know that T of n equals, and I'm just copying the structure, the number for the initial is going to be 15 because they told us that number, plus, because our pattern is adding, 3n. Now, when you get an equation like this, sometimes it's not clear if you're correct or not, and sometimes people have a little bit of doubt, like, how do I know if it's correct? You have 2 options. Easiest way, check the key. Second option, it's a little bit more complex, but you could do it, is you can actually test your equation. Remember how I made a table? Think of each pair of numbers in the table as variables. So for example, the 1 and the 18. The 1 is like an n, and the 18 is the t of n, according to the way we label sequences. And I'll talk about that notation eventually, but for now you can just notice that's a carryover from the Desmos activity. That was just the way it was labeled. If I test my equation, I can plug in 18 where it says t of n equals 15 plus 3 times. I can plug in 1 where the n was, and I can test. Is this true? I have 15 plus 3 times 1 is 3. 15 plus 3 is 18. Hey, yeah, that is going to be true. That actually works. So sometimes if you're not sure about an equation, you can test it. You can build a little table and test. If that sounds like too much work, you can check the answer key as well. And if you feel like you don't need to check because this is super obvious and easy for you, that's great too. But if you think you've got the hang of this idea, try letter D. It's another similar situation. They're going to give you an initial value, and they're going to describe the adder. So see if you can translate those things into this equation structure. In the next video, we'll make sure you're okay with that, and then we'll make sure that we move on to the next idea.